Alrighty then. Hmm. Forgot the T chapter. Okay. Introducing classes. The class is at the core of Java. It is a logical construct upon which this entire language is built because it defines the shape and nature of an object. As such, the class forms the basis for object oriented programming in Java. Any concept you wish to implement in a Java program must be encapsulated within a class. Okay. Because the class is so fundamental to Java, this and the next few chapters will be devoted to it. Here, you will be introduced to the basic elements of a class and learn how a class can be used to create objects. You will also learn about methods, constructors, and this keyword. Okay. Class fundamentals. Classes have been used since the beginning of this book. However, until now, only the most rudimentary form of class has been shown. The classes created in the preceding chapters primarily exist simply to encapsulate the main method, which has been used to demonstrate the basics of Java syntax. As you will see, classes are substantially more powerful than the limited ones presented so far. Perhaps the most important thing to understand about a class is that it defines a new data type. Once defined, this new type can be used to create objects of that type. Thus, a class is a template for an object. An object is an instance of a class. Because an object is an instance of a class, you will often see the two words object and instance used interchangeably. Okay. The general form of a class. When you define a class, you declare its exact form and nature. You do this by specifying the data that it contains and code that operates on that data. While very simple classes may contain only code or only data, most real-world classes contain both. As you will see, a class's code defines the interface to its data. Okay. A class is declared by using the class keyword. The classes that have been used up to this point are actually very limited example of its complete form. Classes can and usually do get much more complex. A simplified general form of a class is shown here. Okay. Then the data or variables defined within a class are called instance variables. The code contained within the code contained within the code is contained within methods. Collectively, the methods and variables defined within a class are called members of the class. In most cases, the instance variables are acted upon and accessed by the methods defined for that class. Thus, a general rule, it is the methods that determine how a class's data can be used. Okay. Variables defined within a class are called instance variables because each instance of the class, that is, each object of that class, contains its own copy of these variables. Thus, the data for one object is separate and unique from the data for another. Okay, we will come back to this point shortly, but it is an important concept to learn early. All methods have the same general form as main, which we have been using thus far. However, most method will not be specified as static or public. Notice that the general form of a class does not specify a main method. Java classes do not need to have main method. You only specify one if that class is the starting point of your program. Further, some kinds of Java application don't require a main method at all. A simple class. Let's begin our study of the class with a simple example. Let's study our class. Let's begin our study of the class with a simple example. Here is a class called box that defines three instance variable with height and depth. Currently, box does not contain any method. Okay. As stated, a class defines new type of data. As stated, a class defines a new type of data. In this case, the new type of data is called box. You will use this name to declare objects of type box. It is important to remember that a class declaration only creates a template. It does not create an actual object. This preceding code does not cause any objects of type box to contain into existence. To actually create a box object, you will use the statement as follows: box myBox equals new box. Right. Okay, after the statement executes, myBox will refer to an instance of box. Okay. After this statement executes, myBox will refer to an instance of box. Thus, it will have physical reality. For the moment, don't worry about the details of this statement. As mentioned earlier, each time you create an instance of a class, you are creating an object that contains its own copy of each instance variable defined by the class. Thus, every box object will contain its own copies of the instance variables with height and depth. To access these variables, you will use the dot operator. The dot operator links the name of the object with the name of the instance variable. For example, to assign the width variable myBox the value 100, you would use something like myBox.width equals 100. This statement tells the compiler to assign the copy of width that is contained within the myBox value, the myBox object, the value of 100. In general, you use the dot operator to access both the instance variable and the methods within an object. Okay. One other point, although commonly referred to as dot operator, the formal specification for Java categorizes as the dot as a separator. However, since the use of term dot operator is widespread, it is used in this book. Okay. So here's a complete program that uses box class. Okay. So let me see. A simple class. Okay. So let's make okay. Alright. So we have this box class. Let me write it up real quick. A program that uses box class. Program that uses box class. So I have class box which defines width, height and depth. Okay, this class declares an object of this class declares an object of type box. So we will, okay, class box demo. Then we have public static void main box my box equals new box. Then we double volume and assign values to my box instance variable. Assign values to my box instance variable. So box chart width equals 10, my box chart height equals 20, and box chart depth equals 15. Okay, then we compute the volume. Compute the volume of box. So go to volume. Um, okay, then go volume equals my box dot width times my box dot height times my box dot depth. Okay. Then we simply print out the volume. Let me call box demo dot java, and I should have two class files, right? Yeah. Okay. Then we go java box demo. Alright. So we come back. You should call the file that contains this program boxdemo.java, because main method is in this class called boxdemo, not the class called box. Okay, when you compile this program, you will find two .class files have been created, one for box and one for boxdemo. The Java compiler automatically puts each class into its own class file. It is not necessary for both box and boxdemo class to actually be in the same source file. You could put each class in its own file. Okay, called box.java and boxdemo.java respectively. Okay. Now to run this program, you must execute boxdemo.class. When you do, you will see the following output. Okay. So I have to put okay. Okay. So I have, so just a quick, we name this file boxdemo.java because that is the class which contains the main method. Okay. Then we have, as stated earlier, each object has its own copies. Of its instance variable. This means that if you have two box objects, each has its own copy of depth, width, and height. It is important to understand that changes to the instance variable of one object have no effect on the instance variables of another. Okay. For example, the following program declares two box objects. We have two box objects. So we have two. Okay, so we compute volume of first object and volume of second object. Okay, As you can see, myBox1's data is completely separate from the data contained in myBox2, okay, declaring objects. As just explained, when you create a class, you are creating a new data type. You can use you can use this type to declare objects. Okay, you can use this type to declare objects of that type. However, obtaining objects of a class is a two-step process. First, you must declare a variable of the class type. This variable does not define an object. Instead, it is simply a variable that can refer to an object. Okay. Second, you must acquire an actual physical copy of that object and assign it to the variable. You can do this using the new operator. Okay, so first, all right. So check the two-step process. First, you must declare a variable of the class type. The variable does not define an object. Instead, it is simply a variable that can refer to an object. You must acquire an actual physical copy of the object and assign it to the variable. You can do this using the new operator. The new operator dynamically allocates, that is, it allocates at runtime memory for an object and returns a reference to it. Okay. This reference is essentially the address in memory of the object allocated by new. This reference is then stored in a variable. Thus, in Java, all classes must be dynamically allocated. Okay. Okay, let's look at the details of this procedure. Alright. In the preceding sample programs, a line similar to the following is used. Box myBox equals new box. This statement combines two steps just described. It can be rewritten like this to show, okay, we create box myBox, declare reference to an object, then allocates a box object. The first line declares myBox as a reference to an object of type box. At this point, myBox does not yet refer to an actual object. The next line allocates an object and assigns a reference to it to myBox. After the second line execute, you can use myBox as if it were a box object, but in reality myBox simply holds, in essence, the memory address of the actual box object. Okay. Closer look at new. As just explained, the new operator dynamically allocates memory for an object in the context of an assignment. It has this general form: class variable equals new class name. Okay. Here, class variable is a variable of the class type being created. The class name is the name of the class that is being instantiated. The class name followed by parentheses specify the constructor of class. A constructor defines what occurs when an object of a class is created. Okay. Constructors are an important part of all classes and have many significant attributes. Most real-world classes explicitly define their own constructors within their class definition. Okay, most real-world classes explicitly define their own constructors within their class definition. However, if no explicit constructor is specified, then Java will automatically supply a default constructor. This is the case with box. For now, we will use default constructor. Soon you will define your own constructor. Okay. So at this point you might be wondering, why do you need to use new for such thing as integers or characters? Why do you not need to use new for such thing as integers or characters? The answer is that Java's primitive type are not implemented as objects. Rather, they are implemented as normal variables. This is done in the interest of efficiency. As you will see, objects have many features and attributes that require Java to treat them differently than it treats the primitive type. By not applying the same overhead to primitives that applies to objects, Java can implement the primitive types more efficiently. Okay. Later you will see object versions of the primitive types that are available for your use in those situations in which complete objects of these types are needed. It is important to understand that new allocates memory for an object during runtime. The advantage of this approach is that your program can create as many or as few objects as it needs during the execution of your program. However, since memory is finite, it is possible that new will not be allocate memory for an object because insufficient memory exists. If this happens, a runtime exception will occur. You will learn how to handle exceptions in chapter 10. For sample programs in this book, you won't need to worry about running out of memory, but you will need to consider this possibility in a real world program you write. Okay. Let's once again review the distinction between a class and an object. Alright. A class creates okay. A class creates a class reference to n. Okay, so all the variables simply refer to things. Okay. A class creates a new data type that can be used to create objects. That is, a class creates a logical framework that defines the relationship between its members. When you declare an object of a class, you are creating an instance of that class. Thus a class is a logical construct. An object has physical reality. That is, an object occupies space in memory. It is important to keep this distinction clearly in mind. Okay. Assigning object reference variables. Object reference variables act differently than you might expect when assignment takes place. Okay. So we have box b1 equals new box, and then box b2 equals b1. Okay. You might think that b2 is being assigned a reference to a copy of object referred to by b1. That is, you might think that b1 and b2 refer to separate and distinct objects. However, this would be wrong. Instead, after this fragment executes, b1 and b2 will both refer to the same object. The assignment of b1 to b2 did not allocate any memory or copy any part of the original object. It simply makes b2 refer to the same object as this b1. Thus, any change made to the object through b2 will affect the object in which b1 is referring, since they are the same object. Okay. Although b1 and b2 both refer to same object, they are not linked in any other way. For example, a subsequent assignment to b1 will simply unhook b1 from the original object without affecting the object or affecting b2. Okay. So we put b1 equals null, but it doesn't affect the object that exists in memory, right? Here b1 has been set to null, but b2 still points to the original object. Remember, when you assign one object reference variable to another object reference variable, you're not creating a copy of the object, you're only making a copy of the reference. Okay. Then we have introducing methods. A simple class. Okay. As mentioned at the beginning of this chapter, classes usually consist of two things: instance variables and methods. The topic of methods is a large one because Java gives them so much power and flexibility. In fact, much of the next chapter is devoted to methods. However, there are some fundamentals that you need to learn so that you can begin to add methods to your classes. This is the general form of a method: type name, parameter list, and then body of a method. Here, type specifies the type of data returned by the method. This can be any valid type, including class types that you create. If method does not return a value, its return type must be void. Okay. The name of the method is specified by can be any legal identifier. Other than those already used by other items within the current scope. Okay, the parameter list is a sequence of type and identifier pairs separated by commas. Parameters are essentially variables that receive the values of the arguments passed to the method when its state is called. If the method has no parameters, then the parameter list will be empty. Methods that have return type other than void return a value to the calling routine using the following form: return and then value. Okay. Here value is the value returned. In the next few sections, you will see how to create various types of methods, including those that take parameters and those that return values. Okay. Adding a method to the box class. Although it is perfectly fine to create a class that contains only data, it rarely happens. Most of the time you will use methods to access the instance variables defined by the class. In fact, method defines the interface to most classes. This allows the class implementation to hide the specific layout of internal data structures behind cleaner method abstractions. In addition to defining methods that provide access to data, you can also define methods that are used internally by the class itself. Okay. Let's begin by adding a method to box class. It may have occurred to you while looking at the preceding programs that the computation of box's volume was something that was best handled by the box class rather than the box demo class. After all, since the volume of a box is dependent upon the size of the box, it makes sense to have the box class computed. To do so, you must add a method to box. Okay, so we have void volume, display volume of a box. Say volume is, then we compute the volume. Right. The program, let me create this program. Okay. Okay, so I have this print. I'll just print volume is simply volume. Okay, then we will create box demo. Maybe okay, get it. Maybe I should okay. First of all, close it here. Then I want to rename it box demo to box 3.java. Then I want to move box demo 3 to one class. Yes, okay. So okay, so I want to go to box demo 3.java. Yes, okay. Great. Box demo 3. Right, then we create two objects. The object reference variables. Okay, then assign value to my box 1's instance variables. Assign values to my box 1's instance variables. So my box 1 dot width equals 10, 2015. This is width, height, and depth. Then we do the same for second one. Assign values to my box 2's instance variable, and then the values are 369. Okay. 3, 6, 9. Okay. Then we display the volume of first box and display the volume of second box. Okay. Display the volume of first box. So I go my box 1 dot volume, right. Okay. Then display the volume of second box. So my box 2 dot volume. Okay. Then we go Java. Oh, sorry. I was box demo 3. Yes, sir. Java box demo 3. Yeah, okay. Right, okay. So look closely at the following two lines of code. My box 1 dot volume, my box 2 dot volume. First line here. The first line here invokes the volume method on mybox1, that is, it calls volume relative to the mybox1 object using the object's name followed by the dot operator. Thus the call to mybox volume, mybox1.volume, displays the volume of the box defined by mybox1, and the call to mybox2.volume displays the volume of the box defined by mybox2. Each time volume is invoked, it displays the volume for the specified box. If you are unfamiliar with the concept of calling a method, the following discussion will help clear things up. When mybox1.volume is executed, Java runtime does system transfer control to the code defined inside volume. After the statement inside volume has been executed, control is returned to the calling routine and execution resumes with the line of code following the call. In the most general sense, a method is Java's way of implementing subroutines. This is something very important to notice inside the volume method. The instance variables width, height, and depth are referred to directly. This preceding, without preceding them with an object name or dot operator. When a method uses an instance variable that is defined by its class, it does so directly without explicit reference to an object and without use of the dot operator. This is easy to understand if you think about it. A box is always invoked relative to some object of its class. Once this invocation has occurred, the object is known. Thus, within a method, there is no need to specify the object a second time. This means the width, height, and depth inside volume implicitly refer to copies of those variables found in the object that invokes volume. Okay. Let's review. When an instance variable is accessed by code that is not part of the class in which that instance variable is defined. So let's review. An instance variable is accessed by code that is not part of the class in which the instance variable is defined. It must be done through an object. When an instance variable is accessed by code that is not part of the class okay, by user dot. However, when an instance variable is accessed by code that is part of the same class as the instance variable, that variable can be referred to directly. The same thing applies to methods. Okay. Returning a value. While the implementation of volume does move the computation of a box's volume inside the box class where it belongs, it is not the best way to do it. Okay. For example, what if another part of a program wanted to know the what does it want to know? To know the volume of a box but not display its value. A better way to implement volume is to have it compute the volume of the box and return the result to the caller. Okay. The following example, an improved version of the preceding program, does that. Okay. Now volume returns the volume of a box. Okay. So let's write another file. Using methods to return value. Okay, I will simply copy. Okay, so much of the things are the same. I'll just make some adjustments. So I'll go double volume. Let's get rid of this. And go return. There we go. Then we have this volume, then we display. Okay. So we go, then we create double volume variable to show the volume. Store the computed volume, and I can simply do this. Okay. Alright, so volume is okay. As you can see, when volume is called, it is put on the right side of an assignment statement. On the left is a variable, in this case vol, that will receive the value returned by volume. Okay. Thus okay. execute the value volume box1 dot volume. Alright, so where was I? Yes, okay. The one executes, so volume equals box1 dot volume executes the value of volume box my box1 dot volume is 3000, and this value is then stored in vol. There are two important things to understand about returning values. The type of data returned by a method must be compatible with the return type specified by the method. For example, if the return type of some method is boolean, you could not return an integer, right? Okay. Then the variable receiving the value returned by a method, such as vol in this case, must also be compatible with the return type of the method. One more point, the preceding program can be written a bit more efficiently because there is actually no need for volume variable. The call to volume could have been used in the print line statement directly, like volume is plus my box1 dot volume. In this case, print line is executed, my box1 dot volume will be called automatically and its value will be passed to print line. Okay. Adding a method that takes parameters. Okay. While some methods don't need parameters, most do. Parameters allow a method to be generalized. That is, a parameter method can operate on a variety of data and or used in a number of slightly different situations. Okay, so here is a simple example. Here int square returns 10 times 10. While this method does indeed return the value of 10 squared, it is very limited. Its use is very limited. However, if you modified the method so that it takes parameters as shown next, then you can make square much more easy. So int square int I equals return I times I. Now square will return the square of whatever value it is called with. That is, square is now a general purpose method that can compute the square of any integer value rather than just 10. Okay. Here's an example. So int xy square 5 25 981. Then okay. In the first call to square, the value 5 will be passed into parentheses I. Okay. Parentheses I. In the in the second in the second call, I will receive value 9. The third invocation passes the value of 5, which is 2 in this example. All these examples shows square is able to return the square of whatever data it is passed. It is important to keep the two terms parameter and argument straight. A parameter is a variable defined by a method that receives a value when the method is called. For example, int square I is a parameter. An argument is the value that is passed by a method when it is invoked. For example, square 100. Okay. Inside square, the parameter I receives that value. You can use a parameterized method to improve the box class. In the preceding example, the dimensions of each box had to be set separately, right? Be set separately uh, by the use of sequence statements such as my box 1 width equals this, height equals this, depth equals this. While this code works, it is troubling for two reasons. First, it is clumsy and error prone. For example, it would be easy to forget to set a dimension. Second, in well-designed Java programs, instance variables should be accessed only through method defined by their class. Okay. In the future, you can change the behavior of a method, but you can't change the behavior of an exposed instance variable. Okay. So thus, a better approach to setting the dimensions of a box is to create a method that takes the dimension of a box in its parameters and sets each instruction sets uh, sets each instance variable appropriately. This concept is implemented by the following program. Okay, so let's create a new file. Okay, let's copy all that stuff and using methods to using parameterized methods for setting values to instance variables. Okay, so I'll create our second function is sets dimensions of box. Sets dimensions of the box. Okay, so we have void set of double w, double height and double depth. So now go width equals height equals h and depth equals d. Right, and so we initialize, then we have this and get rid of this. We say initialize each box, initialize each box, and we have my box 1 dot set 10 20 15. Then my box 2 dot set dimensions is 3 6 and 9. Okay, and everything works the same. Okay, I should box demo 4.java can't find box demo 4. Have I not saved this? Box demo 4 dot okay, so Java C box demo 4 dot java box demo 4. Okay, box demo 4 could not be found. Oh, my bad. Right, my bad. There we go. Okay, so I have to rename this to box demo 5. Okay, and let's see. There we go. Okay, so now as you can see, the set dimension method is used to set the dimensions of each box. For example, when you say my box 1 dot set dimension 10 20 15 is executed, 10 is copied into parameter w, 20 is copied into parameter h, and 15 is copied into parameter d. Inside set dimension, the values of w, H and D are then assigned to width, height and depth respectively. Okay. For many readers, the concept presented in the preceding sections will be familiar. However, if such things are as method calls, arguments and parameters are new to you, then you might want to take some time to experiment before moving on. The concepts of the method, invocation, parameters and return values are fundamental to Java programming. Okay, then we move on to constructors. It can be tedious to initialize all the variables in a class each time an instance is created. Okay. It can be tedious to initialize all of the variables in a class each time an instance is created. Even when you add convenience methods like setDem, it would be simpler and more concise to have all of the setup done at the time the object is first created. Because the requirement for initialization is so common, Java allows objects to initialize themselves when they are created. This automatic initialization is performed through the use of a constructor. Okay. A constructor initializes an object immediately upon creation. It has the same name as the class in which it resides and is syntactically similar to a method. Once defined, the constructor is automatically called when the object is created before the new operator completes. Once defined, the constructor is automatically called when the object is created before the new operator completes. Constructor looks a little strange because they have no return type, not even void. This is because the implicit return type of class constructor is the class itself. Okay. Then we have, it is the constructor's job to initialize the internal state of an object so that the code creating an instance will have a fully initialized usable object immediately. Okay, you can rework the box example so that the dimensions of a box are automatically initialized when an object is constructed. To do so, replace set dimension with a constructor. Okay. So we have in the constructor's job to initialize the internal state of an object so that code creating an instance will have fully initialized usable object immediately. Right. Okay. You can rework the box example so that the dimensions of a box are automatically initialized when an object is constructed. Oh. To do so, replace setDem with a constructor. Let's begin by defining a simple constructor that sets the dimensions of each box to the same values. Okay, so we have within the box we set with 10 by 10. Okay, you do this. Okay. So as you can see, both myBox1 and myBox2 were initialized by the box constructor when they were created. Since the constructor gives all boxes the same dimensions, 10 by 10 by 10, both myBox1 and myBox2 will have the same volume. The print line statement inside box is for the sake of illustration only. Most construction will not display anything. They will simply initialize the object. Okay. Before moving on, let's re-examine the new operator. As you know, when you allocate an object, you use the following general form: class variable equals new class name. Now you understand why the parentheses are needed after the class name. What is actually happening is the constructor for that class is being called. Thus in the line, this new box is calling box constructor. When you do not implicitly define a constructor, for a class, then Java creates a default constructor for the class. This is why the preceding line of code worked in earlier versions of Box that did not define a constructor. When using a default constructor, all non-initialized instance variables will have their default values, which are 0, null, and false for numeric types, reference types, and booleans respectively. The default constructor is often sufficient for simple classes, but it usually won't do more for sophisticated ones. Once you define your own constructor, the default constructor is no longer used. Okay. So parameterized constructors. Okay, I think. Okay, we can do this. Okay. While the box constructor in the preceding example does initialize a box object, it is not very useful. All boxes have the same dimensions. What is needed is a way to construct box objects of various dimensions. The easy solution is to use parameters to the constructor. Okay, as you can probably guess, this makes it much more useful. For example, the following version of box defines the parameterized constructor that that sets the dimensions of a box as specified by those parameters. Pay special attention to how box objects are created. Okay, so box demo 6 chapter. Okay, parameterized constructors. So we have class box, then we define double width, double height, and double depth. Then we have our constructor box, width, double height, and double depth. There you go. Width equals this, height equals height, and depth equals depth. Okay, and then we have the same computes volume, double volume, return width times height times depth. Okay, then we go to class box demo 6. And then we go public static void main string args. Now we define box in a different way. Declare, allocate, and initialize box objects. Declare, allocate, and initialize box objects. Alright, so we have box my box 1 equals new box 10, 20, and 15. Box my box 2 box 3, 6, 9. Then we have a double volume. We copy the rest from here. Right. Then we run box demo 6 Java. Alright. Okay, the output is shown here. As you can see, each object is initialized as specified in the parameters to its constructor. The values 20, 10, 20, 15 are passed to box constructor when the new creates an object. Thus, my box 1's copy of width, height, and depth will contain the values of 20, 50, respectively. Okay, that's enough for today.